So our first lesson for Unit 5 here in 930, we're going to be talking about radicals here in Unit 5. So you started really talking just a little bit about radicals at the end of Unit 4 with our fractional exponents, but we're really going to dive deep into those in this unit here in Unit 5. So we're going to start off with the basics and just how to simplify a radical expression. So we're going to start with when we have a square root of a perfect square, and then we're going to talk about what to do when you have the square root of a number that is not a perfect square. So that's the goal for today. So as a warm-up, it really will help you to know and memorize the first 15 perfect squares. Okay, so you know, what we're trying to do is get you to write it, but write it using a radical. So for example, 1 would be the square root of 1. So first perfect square that we have is 1. 2 would be the square root of 4. So the second perfect square that we have is 4, and so on and so on and so on. So see how many of those you can fill in right now. Pause your video and fill in as many as you can. All right, so if we continue here then, so 3 is the square root of 9. 4 is the square root of 16. 5 is the square root of 25. So there's the first 5 perfect squares. Hopefully you knew those. Then continuing on, we have 6 is the square root of 36. 7 is the square root of 49. 8 is the square root of 64. 9 is the square root of 81. And 10 is the square root of 100. So there's the first 10 perfect squares. So hopefully, again, you knew all those. These last 5 are maybe the ones that you didn't know so well, or maybe you knew a couple, but not all of them. So make sure that you have these written down. Look at them, memorize them if you can. The more you'll know these, the better. So 11 is the square root of 121. 12 is the square root of 144. 13 is the square root of 169. 14 is the square root of 196. Those get confused a lot, but I just remember to switch the order. You know, 169 is less than 196. 13 is less than 14, that kind of idea, but those ones definitely are tricky. And then 15, is the square root of 225. So it is going to be super important. It'll save you so much time if you have those first 15 memorized, or make a list that you keep right next to you at all times. It'll really help the process in this entire unit. If you can do more than that, if you know 16, 17, 18, that would be awesome. But if you can at least know these 15, it will really, really help. All right, so let's talk about then how we're going to use that idea, or get more into this idea of a radical. So a square root really means what number times itself 2 times gives you the number inside, right? That's what a square root means. So for example, if you have the square root of 16, what number times itself 2 times gives you the number inside? Well, 4 times 4 equals 16. So the square root of 16 equals 4, right? That's the idea between a square with a square root. So we talked about all kinds of roots at the end of Unit 4, third roots, eighth roots, things like that, right? So we're only focusing on square roots. So this would be the little invisible 2 right up here if you wanted to, you know. If we wanted to put that little index of 2 on there, you could. But that's the idea behind a square root. And those are the only roots we're going to be dealing with here in Unit 5. So the only thing is, we're going to take it beyond just numbers here, and we're going to have some variables and things going on in there too. So we need to decide, is the following a perfect square or not, right? So can you do, if I had the square root of x squared, is x squared a perfect square? Is there something times itself 2 times that would give you x squared? So the answer to this one is yes. Right? Definitely. X squared, the square root of x squared, this would be x times x equals x squared, right? So that means the square root of x squared equals x. So yes, x squared is a perfect square. What about x to the third? Is there something times itself that would give us x to the third? Something times itself that would give us x to the third. No, I don't think so, right? X squared times x equals x to the third. That's not something times itself. So this one would be no. All right, how about x to the fourth? X squared times x squared, right? That's something times itself, which would give us x to the fourth. So that one is a yes. So the square root of x to the fourth equals x squared, right? X squared times itself gives us x to the fourth. How about x to the fifth? I think x to the fifth is a no. That would have to be x to the second times x to the third. It could be x to the first times x to the fourth, but nothing times itself would give me x to the fifth. So are you noticing a pattern here? Let's see. So x to the second was a yes. X to the third was a no. X to the fourth was a yes. X to the fifth was a no. So if you're noticing, hopefully you're picking up on the pattern that anything with an even exponent, any variable with an even exponent is a perfect square. Any variable with an even exponent is a perfect square. So then x to the 10th, well, let's think about that. X to the 10th, 10 is an even number, so the answer would be yes, right? X to the 5th times x to the 5th equals x to the 10th. Or you can think of it kind of, I don't know if it helps you here, right? But remember that square root in a fractional exponent, the square root really means to the 1/2 power. So this is really x to the 10th to the 1/2 power. Well, yeah, you can do 10 times a half, you get x to the 5th, right? That's how we kind of figure out those variables. So as long as it has an even exponent, you can divide it by 2. And then whatever you divide by 2, that's your answer. When you take the square root and then you divide that exponent by 2, that's your answer. How about x to the 21st? The answer is no, right? 21 is not an even number. All right, so you're looking for those even exponents to be perfect squares, and then you cut that exponent in half, and that's what you get as your answer. Okay, so taking the square root of a perfect square, not too difficult. Square root of 16 is 4. Square root of 64 is 8. The question is, what happens when we get these square roots of non-perfect squares? So if you typed in the square root of 50 into your calculator, you would get a decimal that never ever ends. Now sometimes estimating that decimal is good enough for us, just getting a rough idea of where that number would land. I think last year in 715 you talked about how to figure out what two perfect squares does it fall between, and so giving you an idea of where it might land on the number line. But here now in 930, we want to make sure that we can get exact answers. And when we round a decimal, it's not exact. So what we want to do is come up with a way that we can represent the exact answer for the square root of 50 and simplify it as much as we can. So here's the process for doing that. What we look for is what factors of 50 are there where one of those factors is a perfect square. What factors of 50 are there where one of the factors is a perfect square? Okay, so think of the factors of 50. Now the factors are numbers that multiply together to give you 50. So you might think 5 and 10. Those are both factors of 50, but neither 5 or 10 are perfect squares, so that's not really what I'm looking for. Another set of factors of 50 would be 25 and 2. Okay, so I'm going to break this 50 into factors. Now, I like to represent this with a factor tree. So it looks like this, and it just means that the two things multiplied together give you 50. Now, you could represent that like square root of 50 equals 25 times 2, all inside the radical right there, and just write a times sign in between them. If you like that better, that's perfectly fine. You can do that too, either way. Both mean the same thing. So what we're looking for then is which one of those is a perfect square. So the square root of 25 is a perfect square. So the square root of 25 is 5. So that 5 is no longer inside the radical. The square root of 2 is not a perfect square, so it stays as the square root of 2. So my fully simplified answer for number 1 would be 5 radical 2. So I look for the factors where one of the factors is a perfect square, and I pull that out to the front, take the square root, pull it out to the front. Anything left is going to stay inside the radical. Now we want to keep doing that until you can't find any more perfect squares inside the radical. So my factors of 2 are just 2 and 1. That's it. Neither one is a perfect square. So that's how I know when I'm finished. Okay? So keep going until you can't do it anymore. So let's go look at here at number 2 then. So the square root of 32. Find the factors of 32 where one of them is a perfect square, and then simplify as much as you can. You can pause your video here and see if you can do this one. All right, so if I look at 32, I would say that my factors of 32 are going to be, well, let's see, 4 and 8 would be one set of factors, right? Square root of 4 and the square root of 8. All right, so the square root of 4, that's a perfect square. So square root of 4 is 2. The square root of 8 is not a perfect square. So that's going to stay the square root of 8. Now, you could have done this another way as well, right? Maybe you didn't see that the factors were 4 and 8. Maybe you saw the factors could have been the square root of 16 and the square root of 2, right? 16 times 2 gives me 32. Well then, square root of 16, that's a perfect square. So the square root of 16 is 4. 2 is not a perfect square, so that stays inside as radical 2. Now the problem is, these two should simplify to be the same thing. So what's wrong? Hopefully you noticed here on the first way that I did this, I said square root of 8, but that square root of 8, that's not finished yet, right? I can still keep going. The square root of 8 is really the square root of 4 times the square root of 2. 4 is still a perfect square, so I have to keep going. If I can find more perfect squares as factors, even of what's left, then I have to keep doing it. All right, so for this one then, square root of 4, that's a perfect square. So I'm going to bring that's going to become a 2 outside. The square root of 2 is going to stay inside. But I already had the 2 on the outside from before. Now remember, all of these are factors. So I am going to make sure that I multiply everything together. So if you pull more than one thing to the outside, they get multiplied together on the outside. If you have more than one thing left on the inside, they would get multiplied together on the inside because all of these are factors. So everything is multiplied. So my final answer here then, I would have 2 times 2, which gives me 4 radical 2. And now you can see that those answers actually match. Now take a look. The first method, we just looked for any old perfect square, right? But we ended up with quite a bit of work. In the second method, I looked for the biggest perfect square that was in there as one of the factors, and I had much less work. So highly recommend looking for the largest perfect square that is one of the factors and not just any perfect square. But if you get stuck, try any perfect square and then just keep going until you can't go any farther. All right, let's try this one then. Here we go. 5 radical 448. So again, we're going to try and reduce the radical 448 into its factors, where one of those factors is the perfect square. And again, try to find the biggest factor that you can, or keep chipping away until you can't do it anymore. Pause your video and see what you can do with number 3. Okay. So if I'm going to try and break down the square root of 448, let's see. This is a tough one because they're really that's a big number, right? It's kind of hard to know. Now, the first thing that jumps out to me, it would probably be the square root of 4. So if I do 4, it would be 4 times 112. That would give me 448. So I definitely have a perfect square. But I was thinking there's got to probably be a perfect square that's bigger than that, or maybe there's another one in there for square root of 112. So the question is, how can you use your calculator to help you break down these radicals, right? So what I would recommend that you do is use your calculator, but instead of typing in any number that you want, type in only perfect squares. So let me get to my calculator. All right, so I have 448. So I could do 448 divided by 4. There's my 112. How about 448 divided by 16? Oh, okay, so that works. How about a bigger perfect square, even bigger than 16? 448 divided by 25. No, I kind of knew that one wasn't going to work. 448 divided by 36. No. 448 divided by, let's see, what are the bigger ones even than that? How about 64? Oh, there we go. So now I have 64 times 7 gives me 448. 7, I think I won't be able to go any farther than that. So what I want to do then is I could do the 4 times 112, but I'd have to keep going. So instead, what I'm going to do is the square root of 64 times the square root of 7. Now I have found the largest perfect square in there. And that's how you can use your calculator to help you out. All right, so again, the square root of 64 is a perfect square. Square root of 64 is 8, so that's going to come on the outside. Square root of 7 is not a perfect square, so it's going to stay in. But don't forget that I already had this 5 on the outside. And remember, since all of these are factors, I'm going to multiply those two things that are now on the outside together. So I have 5 times 8, which gives me 40 radical 7. So there's the final answer for number 3. All right, now number 4, not quite so difficult of a number, thank goodness, but we are throwing our variables into the mix here. So let's see if we can break down number 4. So for number 4, square root of 12, and I have square root of x to the 8th. Now, some people get a little bit intimidated when they get variables. So just remember that this is really the same thing. You can break it down like this into its factors. It's the square root of 12 times the square root of x to the 8th, right? If you want to break it into two separate ones, it helps your brain kind of divide and conquer a little bit. You sure can. You don't have to, right? You could do it all in one here if you wanted to. It's all means the same thing, but sometimes this helps students a little bit more. So let's see, square root of 12, I could break that into the square root of 4 times the square root of 3, right? Now remember, when I'm looking for a perfect square, when I have a variable, I'm looking at an even exponent. When I have x to the 8th, that's an even exponent, so that means that this is a perfect square. So square root of 4 is a perfect square, and x to the 8th is a perfect square. Square root of 4 is 2. Square root of x to the 8th, remember that's where you can really think this is really x to the 8th to the 1/2 power, right? So that becomes x to the 4th. 3 is not a perfect square, so that's what's staying on the inside. So I have 2x to the 4th radical 3 as my final answer for that one. All right, how about number 5 now? Square root of 49x to the 3rd. All right, well, the first thing that jumps out to me on this one is that 49 is a perfect square, so that one's ready to get pulled to the outside. But x to the 3rd, that is not a perfect square, right? Because it's not an even exponent. But all of these other numbers, I was reducing these when they weren't perfect squares, and I had things that I could do. Same thing when I have a variable that's not a perfect square. I'm not just like, well, that's it, can't do anything. What I can do is I can look for its factors, right? I want to find the factors. What things multiply together to give x to the 3rd, where one of them would be a perfect square. And remember that a perfect square is anything with an even exponent. So I can break this down to be square root of x and the square root of x squared, right? X to the first times x to the second would give me x to the third. So x to the second, that's my perfect square. And remember that I want to get the biggest one I can, and I believe that's as big as I can get. So 49 is a perfect square, and x to the second is a perfect square. So square root of 49 is 7. Square root of x to the second is x. And I have a plain old square root of x that is not a perfect square, so that one has to stay on the inside. So 7x radical x is what that looks like reduced. So remember, if your exponent is not an even exponent, that doesn't mean you're done. You can still work on it, split it into its factors so that you get an even exponent, the biggest even exponent you can, and then you'll have one left over. All right, so let's look at number 6. All right, so again, if it helps you, you can break this down into the square root of 72, the square root of x to the 5th, and the square root of y to the 4th. I guess I didn't show that step on the last one, but you could have if you really wanted to, if it helps you. All right, so the square root of 72, this would break into the square root of 36 and the square root of 2, right? Hopefully that one jumped out at you pretty good. Now the square root of x to the 5th. X to the 5th is not a perfect square, so I need to break that one down. Now there's a lot of different ways to do this. You could do square root of x to the 3rd and square root of x to the 2nd, but the square root of x to the 3rd, well, you'd have to keep going on that one, right? Then that one would have to be square root of x and square root of x to the 2nd, and that's a lot of work. So the trick with our variables is when you're trying to find, if you have an odd exponent and you're trying to break it down, take 1 off the square root of x. Put all the rest in the other radical, square root of x to the 4th. And that will be the biggest perfect square in there, okay? So take 1 out and put all the rest in the other radical. Same thing we did here, right? Took 1 out and put all the rest in the other radical, and then there's where your biggest perfect square will be. Okay, so on this one, the square root of 36, that's a perfect square. The square root of x to the 4th, that's a perfect square. The square root of y to the 4th, that's a perfect square. So I have my -2 that was there to start with. I always like to draw an arrow and bring it down. So -2 is already outside. Joining it out there with that -2 will be 6. Square root of 36 is 6. Square root of x to the 4th is x squared. Square root of y to the 4th is y squared. Things that are left inside is the square root of 2 and a plain old x. So I have 2x staying on the inside of that radical. Now I do have to do a little bit of multiplying because I have -2 times 6 on the outside, so my final answer will say -12, x to the 2nd, y to the 2nd, radical 2x. All right, one last one just to make sure that you're feeling confident. Number 7, see what you can do. All right, so if I'm trying to break down square root of 35, well, I think of square root of 7 and the square root of 5. Oh, well, neither one of those are perfect squares. 7 times 5, there's 35 times 1, that won't work. Oh, so 35, I can't break down at all. Sometimes that happens. You can't always reduce every single number into a perfect square factor. So 35, nothing I can do about. So what about this y to the 99th though? 99 is not an even exponent. Now remember the trick. If I need to break down a variable with an odd exponent, I'm going to take one of them off. So I've got the square root of y, and then all the rest go in the other one, square root of y to the 98th. All right, then that square root of y to the 98th, that's an even exponent, so that's a perfect square. And remember, that really means x to the 98th to the 1/2 power, right? What's half of 98? Half of 98 is 49. So I got x to the 49th power is my only perfect square coming to the outside. 35 was not a perfect square and can't break it down. And y need to both stay on the inside. So I have 35y. I apologize. I just realized that I swapped from a y to an x here. This should be a y and a, okay. Clear it up here. So I have y to the 98th to the 1/2 power. So I get y to the 49th outside and radical 35y left on the inside. All right, hopefully you have an idea. We will be practicing simplifying radicals every single day of every single lesson in Unit 5, so you'll get better and better at it the more you do it. So, but notice that knowing those perfect squares really helps, so make sure you memorize those first 15. If you have a variable that has an even exponent, that's a perfect square. If you're trying to simplify a radical that is not a perfect square, break the number inside into its factors where 1 is a perfect square. Keep looking until there are no more perfect square factors. It'll save time if you look for the largest perfect square factors first. When breaking down variables with odd exponents, remember to take 1 off and all the rest go in your other radical, and that will be the largest perfect square factor possible.